This is problem 615. It's on page 344. This is an interesting problem because I could have solved it by just using a whole bunch of rectangles. I mean, in order to minimize the number of rectangles total, I guess I could have taken, let's see, one area, two areas, three areas, four areas. So 4 rows, 4 1/12 BH cubes, located the height of all the centroids of all of these. But I went a different way. Let me show you what I did. Part 1, I chose to take the overall outline. So what am I doing there? Well, I'm taking this rectangle first, and I'm dealing with it. Now you can say, well, wait a second, there's a whole bunch missing out of that rectangle. That's okay, we'll take care of that in a second. But notice that the width is 1.2, the height is 2.4, so my area is 2.4 times 1.2. The location of the centroid of this area, measured from the bottom, which is what I always do, keeps everything easy and straight for me, is half of 2.4. It's 1.2 inches up. So the AIYI product for this area is just these two multiplied by one another, and that comes out to 3.456. We'll talk about the second moment of area here in just a moment. Let's consider the other areas. What other areas are there? Haven't I overcounted? Yeah, so I need to subtract out. So mathematically what I will do is just take this area to not be a positive area, but to be a negative area. In other words, it's not there to balance out the overall shape with the individual shapes, right? It's something that actually is a negative area moment for the first moment balance, for the first area moment balance. Now, its width is 1 inch, right? Because the wall thickness here is 0.1 typical, so I've got a wall over here and a wall over here, so 1.2 minus 2 of 0.1 is just 1 inch. And the height is, well, it's almost 1.5 inches, but not quite. It's minus 0.1 minus 0.1, so 1.3. So the area is 1 inch by 1.3, and so that's what I put in here. But notice I put in a negative sign. I added in that negative sign because this is negative area we're dealing with. It's taking away from the AIYI product. The centroid of this shaded area is just up at half of 1.5 inches. That's 3/4 of an inch, or 0.75. And so the AIYI product is just negative 1.3 times 0.75, and it's okay that it's a negative 0.975 because, again, it's taking away from material that would have been pressing down on that side of the scales when we're trying to find our centroid of the overall shape. Alright, what about the last one? Well, the last one you probably have figured out is just this area right here, right? It's 1 inch wide, it's 0.9 inches wide, so we have an area of negative 0.9 square inches. The height there is up, well, let's see if we can figure it out, 1.5 inches plus half of 0.9. Well, half of 0.9 is 0.45. 0.45 plus 1.5 is 1.95. And again, there's the product, we have negative area. So now, summing all of these, we get 0.726 as our sum of the AIYIs. Now notice I had to put these in as negative areas. I had to put that negative sign in place and then make sure they came out negative over here. Of course they would, because these y's are positive, but they are subtracting away from the area of balance. Now the total area, then, it makes sense, I hope, that you can take the outline area and subtract off these two missing areas. That's what's being done here. We're just summing this whole column. And then, even still, the ratio of these two, the sum of the AIYIs and the total area, is the location of the centroid of the overall shape. Now, not the shape I've got highlighted, but that shape, right? What's left. Now, what about the second moments of area? Well, remember that my first row deals with a rectangle that is an outline of the entire shape. The height of that rectangle is 2.4 and the width is 1.2, so it's pretty simple. 1.2 base, 2.4 height has to be cubed divided by 12. Just 1/12 BH cubed, just like it always is for a rectangle. The distance between the centroid of this outlined area, which is at 1.2, and the centroid of the overall shape, 1.067, there's the overall shape again, that distance difference is not very large, right? The distance between those 2 points is not much. So it's not much of a surprise that the moment of inertia, or the second moment of area of the this outline shape that I'm dragging around, it's not really a surprise that that's pretty close when referenced to the centroid of the overall shape, because the overall shape centroid and the centroid of this outline shape are so close together. They're not very far apart. So these two numbers, the second moment of area of the outline area reference to its own centroidal axis versus the centroidal axis of the overall shape, it's roughly the same. Notice that the next bit, the area that's missing, not only does this contribute negative area, but it contributes negative inertia, or negative second moment of area. And so the width of it is 1 inch. The height of it is 1.3 inches, so it's the 1.3 that gets cubed, divided by 12. And notice I had to be careful and make sure I included my negative sign here. Same thing for the other shape. The other shape's up here. You can see that it's 0.9 high and 1 wide, and we've got the negative sign. Okay. And then the spreadsheet just computes the distance between the centroids of each of these negative areas and the centroid of the overall shape. Takes the difference, and there they are. Okay. You don't have to worry about the fact that this one's negative and this one's positive and this one's negative. You might look at this and say, well, wait a second, these two match and they shouldn't, because this is a positive area and that's a negative area. No, this is just a distance. It's just the distance between the centroid of the shape, whether it's a positive or negative area shape, and the centroid of the overall shape. That's all that is. And it doesn't matter anyway, because it's going to be squared in the next cell. You see, this cell takes F2 and squares it. So the negative sign goes away anyhow, essentially. Now the negative sign from the area is preserved, which is good, because we still want a negative. We're still taking away from the total inertia of the shape because we've removed area. And so you'll notice that rightly both of these terms are negative. As a matter of fact, anytime you have negative area, you should always have a negative inertia regardless of what axis it's referenced to. So just as before, the total second moment of area is just the sum of the second moments of area of all of these, because they're all referenced to the same centroidal horizontal axis going through the centroid of the combined shape. Now that's at 1.067, which makes sense, right? Because just intuitively, if this bar were up at the top, well, then the centroid would be just at 1.2 inches, but since it's down, the centroid of the overall shape must be below 1.2 inches, and of course it came out that way. So this all makes sense. And now we've got our location of the centroid and the moment of inertia of the entire shape about that centroid. And again, don't forget I'm using a horizontal axis, despite the fact that there's a vertical line of symmetry here. That's not the axis I'm summing moments about, right? If I were, I'd be dealing with very different heights, right? The heights would be like 1.2 inches instead of 2.4 inches. But if you look carefully in all of my moment of inertia calculations, it's 2.4 that's cubed, and that indicates that that's the height of the combined figure, or the outline that I was working with earlier.